Your application is live, users are clicking, data is moving, and somewhere in the cloud, a single decision about storage is about to either hold everything together or quietly tear it apart. Here is the dilemma every architect eventually faces. Should each machine own its own private hard drive, or should a whole fleet of machines share one living directory, the same folders, the same files, seen by everyone at once? Get it wrong, and a database starts missing deadlines by milliseconds that feel like forever. Or a dozen web servers write different versions of the same config, and none of them agree on reality. Amazon Web Services offers more than one answer to where do my bytes live? Two of the most important are Amazon Elastic Block Store, EBS, and Amazon Elastic File System, EFS. They both store data. They are not interchangeable. Think of them as rivals with different personalities. EBS is the specialist, tightly coupled, precise, built for one machine that needs speed and control. EFS is the coordinator, generous, networked, built for a crowd that must see the same workspace. This is the story of that rivalry, what each one makes possible, what each one costs you, and how to choose before the wrong storage model becomes the outage you explain on Monday. Start with the lonely machine. In Amazon's cloud, a virtual server is called an EC2 instance, Elastic Compute Cloud. It is a computer you rent by the hour, CPU, memory, network. But a computer without durable storage is a goldfish. Reboot it, and anything written only to temporary local disk can vanish. That is where Amazon Elastic Block Store enters. EBS is high performance block level storage designed specifically for use with EC2. In plain language, it behaves like a virtual hard drive you attach to that one instance. You do not browse folders on EBS the way you browse a shared drive at the office. Under the hood, EBS presents raw blocks, unformatted chunks of disk. Your operating system formats them, partitions them, and mounts them as devices. Root volume on /dev/SDA1. A home partition, swap. Whatever the machine needs. The payoff is intimacy. The volume sits close to the instance. Reads and writes feel like local disk. For a database engine hammering random pages or a boot volume that must come up clean every time, that intimacy is the whole point. EBS volumes store data in block units, highly optimized for random read and write patterns. That matters. Databases and operating systems do not stream neat sequential files all day. They hop around, a page here, an index there. Blocks are built for that hopscotch. There is a catch written into the architecture. EBS is not reachable over the public internet. You mount a volume directly to an EC2 instance, and that instance must live in the same availability zone as the volume. Same building cluster of the cloud, same failure domain for the attachment path. You can detach a volume and reattach it to another instance. Handy when you replace a failed server, but the volume still cannot wander to a different availability zone. Geography, in the cloud sense, is destiny for EBS. Management is hands-on. You choose a size, you pay for the capacity you provision. Whether you fill it or not, you format, you partition. Maximum volume capacity reaches 64 tebibytes. Latency is the prize. Consistent sub-millisecond responses with very high IOPS depending on the volume type you pick. So EBS wins when one machine needs a fast, private workbench. But what happens when the application stops being one machine? Look at the shape of that relationship. One EC2 instance, one EBS volume attached beside it. Inside the volume, the familiar layout of a machine's disk, boot device, home, system paths, all owned by that single compute node. No second server peeking in, no shared folder floating above the rack. This is precision storage, private, attached, fast. Hold that picture, because the next problem shatters it. Modern applications rarely stay lonely. You add a second web server for traffic, then a third. Containers appear. Serverless functions wake up for a few hundred milliseconds and need a config file that must match everyone else's. If each instance only has its own EBS volume, you now have a coordination nightmare. Copy files to every disk, hope deployments stay in sync, build a custom replication layer you will resent at 3 in the morning. What you actually want is simple and ancient, one directory tree, hierarchical folders, files with names, and permission for thousands of machines to open that same tree at the same time. Read a model file, write a shared log, drop a build artifact where the next worker can find it. Block storage alone does not want to be that shared room. You need a different kind of service, a file system that lives above any single instance. Enter Amazon Elastic File System, EFS. EFS is fully managed, serverless, file-level storage. It gives you a shared directory with virtually unlimited scaling. As you add files, capacity grows. As you delete them, it shrinks. You pay for what you consume, storage and throughput, not for a provisioned slab you might never fill. The protocol is standard NFS v4, the same family of network file system ideas Unix administrators have trusted for decades. That means EC2 instances, containers, and serverless functions can all mount the same centralized structure concurrently, thousands of them. Unlike EBS, EFS is not trapped in a single availability zone attachment story. Mount targets appear across zones. A file written in one zone is the same file seen from another. The file system becomes a multi-AZ meeting place rather than a private disk bolted to one chassis. Performance scales with demand. Elastic throughput mode can even scale throughput independently, so a sudden read storm does not require you to manually resize a volume at the worst possible moment. Reach replaces intimacy. That is the bet EFS makes. Now see the architecture. Multiple availability zones, subnets in each, EC2 instances with network interfaces, mount targets bridging compute to a single Amazon EFS file system drawn underneath like a shared foundation. Folders branch inside that foundation, one tree, many clients. Where EBS was a private cable from disk to one server, EFS is a plaza. Everyone who is allowed can walk in and work on the same files. Sharing solves reach. The open question is whether it preserves the same latency and control that made EBS irresistible for databases. Here the rivalry gets honest. Latency first. EBS offers consistent sub-millisecond latency, the kind of snappiness a transactional database treats as oxygen. EFS offers low latency measured in milliseconds, still fast for many workloads, not the same class of feels like local disk for the hottest paths. Concurrent access flips the scoreboard. EBS is typically attached to one EC2 instance. EFS invites thousands of concurrent instances. If your story is multiplayer, EFS is speaking your language. If your story is a single engine chewing indexes, EBS keeps the noise out. Management is philosophy as much as feature. EBS asks you to size, format, and partition. You are the sysadmin of that virtual drive. EFS is serverless and fully AWS managed. You mount it and get on with the application. Picture EBS as a precisely cut workbench in a locked workshop. Every tool in reach, nobody else rearranging your bench. Picture EFS as a warehouse that expands as boxes arrive, with loading docks on every side of the building. Different jobs, different buildings. Max performance numbers tell related stories. EBS delivers very high IOPS depending on volume type, tuned per attachment. EFS can push up to 250,000 read IOPS and 10 gigabytes per second across its shared design, with elastic scaling under load. Durability and availability language in the comparison can trick a hurried reader, so slow down. For EBS, the table highlights 99.999% availability in a single availability zone. For EFS, it highlights 11 nines of durability across multiple availability zones, 99.9999999%. Those are not the same metric dressed in different clothes. One emphasizes how often the single AZ block volume is there for you. The other emphasizes how stubbornly bits survive in a multi AZ file system design. Architects who mix those sentences make bad bets. Capacity differs in kind. An EBS volume is limited to the size you provision, up to 64 TB bytes. A single file on EFS can reach about 47.9 TB bytes, while total file system capacity is described as virtually unlimited. Cost follows the same split. Pay for provisioned capacity on EBS, pay for consumed storage and throughput on EFS. Storage nature is the root fork, raw, unformatted blocks on one side, a shared hierarchical file system on the other. Everything else, latency, concurrency, ops burden, grows from that fork. Neither service wins a beauty contest in the abstract. The workload casts the deciding vote. So when do you choose which rival? Choose Amazon EBS when low latency is non-negotiable, when storage attaches to a single EC2 instance, when you are running databases or boot volumes, the private heart of one machine. That is the specialist's territory. Predictable, attached, block fast. Choose Amazon EFS when multiple instances need shared access, when automatic scaling matters because you refuse to babysit disk sizes, when the application genuinely needs a shared Linux file system, one tree of paths that containers, functions, and servers all understand, a concrete pair of stories, a PostgreSQL primary writing WAL and data pages all day belongs on EBS beside its instance. A fleet of content renderers pulling the same asset pack and writing outputs into a common drop folder belongs on EFS. Swap those assignments and you will feel the friction immediately, either in latency or in the human cost of keeping copies aligned. The opening dilemma resolves not by brand loyalty, but by access pattern, one owner or many, private workbench or shared plaza. Two kinds of storage, one architectural question. EBS made it possible to give a cloud virtual machine a hard drive worthy of serious software, sub-millisecond, high IOPS, detachable within its zone, paid as provisioned capacity. EFS made it possible for a distributed application to share a real file system without inventing one, multi-AZ, NFS v4, elastic, paid as you go. The stakes from the first minute still stand. Wrong storage does not always fail loudly on day one. Sometimes it fails as slow queries, as deployment drift, as an invoice for empty provisioned terabytes, or as a Saturday spent building sync jobs that a file system should have provided. What remains open, the question the field keeps chasing, is how to keep distributed systems simultaneously fast, resilient, simple, and economical as they sprawl across zones, containers, and fleeting functions. Block precision and file reach still pull in different directions. The best architectures do not pretend the tension vanished. They place each workload on the side of the rivalry where it actually thrives. Choose with the access pattern in mind. Then let the bytes live where they belong.